Good morning, everybody. 1/7/2021. Hopefully, 21 is going to be a better year. I'm sure hoping so. So here we go. What happens? What happens if it's not a right triangle? Well, maybe you can make it in a right triangle, but that would be really hard because you don't know enough information. So the cool part is that, thank you. Might be a little too bright there, honey. Perfect. That was my wife. Anyway, what you need to know is if it's not a right triangle, we have a rule, we have a formula that can solve triangles that are not right triangles. It's kind of cool, called the law of sine. It's actually really easy. But the biggest thing is this: there is no hypotenuse. Okay, there is no hypotenuse because it's not a right triangle. So I drew a picture of a triangle, and I've got an angle, and I've got its opposite side. I have another angle and its opposite side. So there's no hypotenuse, just an angle and its opposite side. So you have two opposite sides: angle 1, opposite 1, angle 2, and its opposite side. So the law of sine says this: there's a ratio between the angles. So you can set up the opposite side. I'm going to say opposite 1, side, opposite 1 over the sine, law of sines, over the sine of its angle, has to do with opposites, is equal to opposite 2, side opposite 2 over law of sines, the sine of its opposite. So it has to do with opposites. Side over its opposite sine, side over its sine of its opposite angle. That's it, okay? Now, you can also find the angles using the exact same formula. You don't even have to really write the formula down again, but I will. So to find an angle, set it up again. Same thing, except I'm just going to put the angles on top. So it's called the law of sines. So same ratio. I'm going to go sine of angle 1, theta 1, over its opposite side equals, here's the angle, sine of theta 2 over its opposite side. Okay, so exact same formula, except for the difference is the opposites are on, the sides are on top. If you want to find a side, I always like to put the sides on top. If you want to find the angle, I like to put the angle on top. Now, the only thing, one more thing on this one, if you're looking for an angle, you must, when you're all done, you must then do the sine inverse of whatever answer you get up here. Okay, so let's do a problem. Let's see how it works. Okay, so shift the paper over. Number 1, find the missing angles and sides of this triangle. Okay, so here's my little triangle. I've got my formula. So here's my angle. Let's call that theta 1. And so then it has its opposite right here. Okay, so there's its opposite. I have a 6, a side. That's an opposite side to this angle here. Let's call that theta there. So here's what I have. I have a pair of opposites. If I know a pair of opposites, if you know a pair of opposites, you can do it. Okay, so check it out. Here's what we have. We have theta. I want to find the angle. So I'm going to use this formula. Okay, I'm going to set up the sine of theta 1 over its opposite side is equal to the sine of theta 2 over its opposite side. So check it out. That's an angle, that's an angle. So let's write down what we don't know first. I'm going to go sine of theta over 6. Check it out. Sine of theta over 6, call that theta 1 because it's what I want to find, is equal to sine of 40 over its opposite side, which is 5. Okay, so sine of an angle over its opposite side equals sine of an angle equals its opposite side. Now, to solve this, I'll just simply multiply up by 6, multiply both sides by 6. So I'll rewrite this as a sine of theta equals 6 times the sine of 40 over 5. And then I'm going to use my calculator. And we're just simply going to go, make sure you're in the right mode, right? Correct mode, degree mode, not radian mode. We're going to go 6 times the sine of 40 divided by 5. Enter. Well, that can't be the answer. There's no way. I'm looking for an angle. 0.77 is an angle. That's not an angle. But we've got to find the angle. So we have to do the inverse. We're looking for the angle, so we have to do the sine inverse of that 0.7713, blah, blah, blah. So to find an angle, we have to use the inverse button. So I'm just going to go sine inverse, right, of that answer. So I've got the 0.7713, blah, blah, blah. And I get about a 50.5 degree angle, okay? So here's what I know. This angle is about a 50.5 degrees. Now if I want the other angle, because there are 3 angles in this triangle, well, that's pretty easy. I know that with 3 angles. Keegan, how many degrees is in a triangle? How many degrees in a triangle? Keegan knows. 180, she says, right? Shout it out, Keegan. She says 180, so that's easy. So I go 180, and we're going to subtract out my 40 plus my 50.5. Okay. So to find the third angle, Keegan says that 180 degrees in a triangle plus 50.5. Good thing I got somebody smart around here. So I get an 89.5 degree angle. So the last angle is about an 89.5 degrees. No, I don't draw these to scale, so forgive me, I'm not an artist, okay? That's the way it goes. Okay, now, finally, if I want to find this third side, okay, let's just call this third side x. You cannot use Pythagorean's theorem. No, cannot. No. No Pythagorean theorem, because it's not a right triangle. It's not a right triangle. So you know what we're going to do? We're going to set up and use the law of sines again. So I need to find a side, so I'm going to use the law of sines. Okay, I want to find the opposite, so I'm going to go, okay, opposite, that's x over the sine of its angle. Opposites, right? 89.5 is equal to, right, 5 over the sine of 40. Okay, so I did this. Check my formula out. I went, put it right there. I went opposite side of the sine of its angle equals opposite side of the sine of its angle. Opposite side of the sine of its angle equals opposite side of the sine of its angle. Okay, now I'm going to multiply up my sine of 89.5, so I'm going to rewrite this like this. I'm going to go x is equal to 5 times the sine of 89.5 degrees divided by sine of 40 degrees. I'm just going to use my calculator to do that work. Let my calculator do the work. 5 times the sine of 89.5. Close the parentheses. Close parentheses, otherwise it's going to mess you up. Divided by sine of 40, and I get an answer of about 7.77 or 7.78. Okay, that's that side. 7.78. Okay. All right, we don't really need to do example 2. Real quickly, you can get that angle from 180 degrees and set up the law of sines again. Okay. All right, and we'll do this in class during Zoom. Okay. Now, area. Okay, area. There is a formula for area. Base times height, right? Area of a triangle. Usually, it's going to be 1/2 base times height. Normally, right? Except you don't know the height. You don't know the height. But luckily, we have a formula for that too. Okay. So the area of a triangle, if you don't know the height, okay, you don't know the height. Okay, if you don't know the height, we're going to do this formula. Okay, it is area is equal to 1/2. Now these are adjacent and adjacent. There's no opposite. There's no hypotenuse. These are adjacent because they're next to it. So if you've got an angle, we use the two sides that are next to the angle. Adjacent, adjacent. That's the opposite. We don't really care about the opposite actually. So we're going to go 1/2 adjacent 1 times adjacent 2. And it doesn't really matter which one you call adjacent 1, adjacent 2. Okay. So let's do the area of this triangle here. It's really easy. Area this triangle, let's use the formula. There's no height. Is equal to 1/2 the adjacent, which is 6, times the other adjacent, which is 5, times the sine, times the sine of theta. How did I forget that? I may have to rewrite that. Times the sine of 58. Okay, let me rewrite this formula. Area is equal to 1/2. I'm a little distracted. The news is kind of crazy this day. Adjacent 1 times adjacent 2 times the sine of theta. Okay, that's the formula I want. Okay, so in my calculator I just went 1/2, that's the formula. Adjacent 6 times adjacent 5 times the sine of the angle, not cosine, sine. Okay, let's just use the formula. 0.5 times 6 times 5 times the sine of 58, and I get an answer of about 12.72, and that is the area. It's about 12.72 centimeters squared. Okay, so we'll talk more about this in Zoom. That's all I have. Law signs are easy. Okay, goodbye. See you in Zoom.